Hello, and welcome to the Fundamentals of Digital Image and Video Processing. I'm Angelos Katsagelos, and I'm a professor here at Northwestern University. Images and videos are everywhere, in thousands of scientific, consumer, industrial, entertainment, and artistic applications. One of the reasons for this overabundance of images and videos is the multimedia revolution we are experiencing. For example, 300 million images are uploaded to Facebook every day, while 4 billion hours of video are watched on YouTube every month. Due to the proliferation of digital cameras, we are not just consumers of this multimedia content, but at the same time producers, thus making us prosumers. Most of the everyday images and videos are formed by radiation in a very small part of the electromagnetic spectrum. We can use special sensors to acquire images at a large range of frequencies that are invisible to human eye. You can see an image of a person going through a millimeter wave imager like the ones you encounter at an airport, an infrared image showing the temperature distribution on the body of a person, an image taken with your cell phone, and an X-ray image taken at a doctor's office. This is not the end of the story. The invention of powerful microscopes and telescopes has opened to us the gates of nano and galactic worlds and enabled us to take images of objects that were previously too small or too big to capture. The sizes of the objects you can see now vary from a few nanometers for an AFM image of silicon atoms on the left to hundreds of thousands light years for the Andromeda galaxy on the right. To computers, these images and videos, with all their different characteristics and appearances, are nothing more than 2D or 3D arrays of numbers. So in this course, we will learn how to manipulate or process these multidimensional arrays of numbers by extending the tools and representations that some of you might have studied in a one-dimensional digital signal processing course. The applications of image and video processing tools and techniques are countless. Here are a few examples. When the acquired image is out of focus, image restoration algorithms can bring the sharpness back. In this application, a number of low-resolution images are acquired, and when combined appropriately, a high-resolution image is obtained, revealing additional information. Another application is when we want to squeeze the multimedia data so that they can occupy less space on a storage device. For example, without video compression, a 90-minute movie would take 36 DVDs to store instead of just one. We also compress the multimedia data so that they occupy less bandwidth when transmitted. As you can see in this video, the quality of the received video deteriorates when transmission errors occur, as you might have experienced when using FaceTime. In some instances, we might be interested in finding the edges in an image or a video. This information can be useful in a number of applications such as object tracking, segmentation, restoration, etc. Finally, we might want to colorize a black and white photograph, as is the case with this famous Matisse painting, Bathers by a River, courtesy of the Art Institute of Chicago. In this course, we will cover the tools and techniques which will allow us to analyze any image and video. We will also cover the important technologies and standards behind these applications. So by the end of the course, you'll be able to understand the image and video processing technology and literature. For those of you in research and development, you'll also be able to become contributors to this exciting field and to help push the envelope. I hope you join me in this exciting course.